Let's talk about the border problem. So remember that the original border problem that we looked at in class was this. Without counting one by one, how many squares are in the red border of this 10 by 10 grid? That means there are 10 squares on each side of the grid. And you're supposed to figure out how many squares are in that red border. Now, in class, there are a couple methods that students found. I'll talk about 3 of those methods. There are at least 6 different methods you could use to count. The first method I'll be looking at is this one. If I count 10 on the top and 10 on the bottom, so I'll do 10 on the top plus 10 on the bottom plus what's left on the sides. 8 on the sides for both sides. That would look like 10 plus 10 plus 8 plus 8. So that's one way you could count it. Another way you could count it is by thinking, well, I could go 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to go all the way to the edge. And then I'm going to start at the edge and create my new line. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, I'm not going all the way to the edge. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice how nothing's overlapping, and I'm using 9 each time. So that would be 9 times 4. Another way someone might count it is by doing something like this. Again, I'm going to use that 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 over here, 8 over here, 8 here. And then I still haven't counted any corners, so I need to add those in at the end. One corner, 2, 3, 4. So that would look like something like this. 8 times 4 for the 4 sides, plus the 4 corners. All right. Now let's think about what the problem from the quiz was asking, which was for an n by n grid. So when we are thinking about generalizing the border problem, we are trying to find a pattern in how we count the squares in each of these methods. I'm going to choose one method to focus on. Let's pick method 1. 10 plus 10 plus 8 plus 8. I'm going to draw in my 10 by 10 grid how I counted that. So I had 10 on the top, 10 on the bottom, and 8 on the sides. Now let's think what that same method would look like for a 15 by 15 grid. Well, I would count 15 on the top, 15 on the bottom, and now we think about this section would be 15, not counting these 2 corner pieces, because I already counted them when I figured out the 15 on the top and on the bottom. So if I'm not counting 2 corner pieces, I need to do 15 minus 2, which is 13. So I'd have 13 here, 13 here. I can apply that same pattern to an 877 by 877 grid. That means there are 877 squares on each side. Well, I'd have the full 877 on the top and bottom, like always. But then I would have on the sides 877 minus the 2 corners that we already counted, 875. So to 875 here, 875 here. Now that you get that general pattern, we are going to not use numbers anymore. We want to use n, because by using n, we can make a general rule for any size grid. If you let n equal 10, then it's like this situation. If you say n is 15, it would be the second situation. So using n by n lets us generalize. We'd have the same sort of pattern going on. And if this is an n by n, pretend n is 10. Well, we had 10, 10 on the top and bottom. When n is 15, it'd be 15 and 15, and so on. So we can tell right away that we'd have n on the top and n on the bottom. Now we got to think about how we got all of these numbers. Each time we took the original number, or the number of squares on one side, and we subtracted 2 from it. So we will do the same thing in our n by n. We take the original number n and we subtract 2 because of these 2 corner pieces. This section also has, I'm going to write it sideways, oops, so that it's fitting in there, n minus 2 squares. N minus 2. So that's how I would generalize and draw in one pattern to represent the border geometrically. And notice how I've also labeled each section with the number of squares. That was another instruction in the problem. And then it asked you to write the long form of the algebraic expression that represents the number of squares in the border. Well, if each section is labeled with how many squares it has, I can figure out the total by just adding all those up. So I'd have n, I'll go around this way, n plus n minus 2 plus n minus 2. And I'll highlight where each of my parts is coming from so you are really understanding it. Okay? Now I want you to think about what would your pattern look like. Maybe you used one of these methods, maybe you used something else. But your answer should use n because we're generalizing. It should have like sections on the grid that you've created, and each section should be labeled.